Chapter 8, Lesson 1, Function Tables. A function is a relation that assigns exactly one output value to one input value. The function rule describes the relationship between each input and output, which is often seen as an expression. We organize the input-output values and the function rule in a function table. In a function, the input value is also known as the independent variable. The value of the output depends upon the input value, so the output value is known as the dependent variable. Example 1. The output is 7 more than the input. Complete the function table for this relation. So we're given a set of input values, 10, 12, and 14, and we know that we have to use this rule, x plus 7, because the output is 7 more than the input. So if the input represents x, the output is x plus 7 because it's 7 more than the input. So let's use this rule to find our outputs. So my first input is 10, which we can plug in for x, add 7 to it to get our output of 17. My next input is 12, which we can put in for x, add 7 to it to get 19. My next input is 14. We can add 7 to it to get 21. Example 2. The output is 5 times the input. So if the input is x, we can use 5x or 5 times x to find our output. So let's complete the function table. My first input is 8. So I can plug in 8 in place of the x. So I have 5 times 8, which gives us our first output value of 40. My next input is 10. So 5 times 10 gives us our next output value of 50. My next input is 12. So I can plug in that input for x, and we get our last output value of 60. Try completing these function tables yourself. Example 3. Find the input values for the function table. So for this example, we're given the output values and the function rule, and we want to find our input values. So I know that our first output is 6, and we did 3 times some number to get to 6. So we can set up the function rule and set it equal to each output and solve using inverse operations to find our input. So my function rule is 3x, and my first output is 6. So I'm going to set 3x equaled to 6. If I were to solve this, I would divide both sides by 3, and we get x equals 2. So my first input value would be 2. Let's plug it into our function rule to check. So if I plug in 2 for x, we'd have 3 times 2, which does equal to 6. My next output is 15. So again, we're going to use our same function rule, 3x, and set it equal to our next output, 15. If I were to solve this for x, we would divide both sides by 3, and we get x equals to 5. So my next input would be 5. Let's check by plugging it into the function rule. 3 times 5 does equal 15, so that's correct. My last output is 21, so again, we're going to use the same function rule, 3x, set it equal to 21. So to solve for x, divide both sides by 3, using inverse operations, we're left with x equals 7. My next input is 7. Let's plug it in to check. 3 times 7 does equal 21, so that's also correct. So here we found our input values given the output and the function rule. Example 4, find the input values for the function table. Again, we're given our output and our function rule, and we want to find our input. So just like in the last example, we're going to take our function rule, 2x minus 1, and set it equal to each output value to find our input. So our first output is 1. So I'm going to set our function rule, 2x minus 1, equal to our output, 1, and solve for x to find our input. So because this is a two-step equation, we need to solve this using order of operations in the reverse order. So first we need to undo any addition or subtraction. So first I'm going to add 1 to both sides. This equals 0 and cancels out. We're left with 2x equals to 2. Now we have a one-step equation. X is being multiplied by 2, so we're going to do the inverse, divide both sides by 2, and we're left with x equals 1. So for the first input, we get 1. Let's plug it into our function rule and check. So we have 2 times 1 minus 1. Now we're going to solve this following order of operations. 2 times 1 gives us 2. 2 minus 1 equals 1, which is our output. So this first input is correct. So now we're going to use our same function rule, 2x minus 1, and set it equal to our next output, which is 3. We're going to solve for x by doing order of operations in the reverse order. So again, the first thing we want to do is add 1 to both sides. Minus 1 plus 1 are inverse operations. They equal 0 and can be canceled out. So we're left with 2x equals to 4. 3 plus 1 is 4. Now this is a one-step equation. X is being multiplied by 2, so we're going to do the inverse and divide both sides by 2. These cancel out. We're left with x equals 2. So our next input value is 2. Let's plug it into our function rule and check if we get an output of 3. So 2 times 2 minus 1. 2 times 2 gives us 4. 4 minus 1 gives us 3. So that's correct. So now we're going to set our function rule, 2x minus 1, to our last output, 5, and solve for x. So we need to add 1 on both sides. These equal 0 and cancel out. So we're left with 2x equals 6. Now we can divide both sides by 2. And we get x equals 3. So that's our last input value. Let's plug it into our function rule. 2 times 3 minus 1. 2 times 3 gives us 6. 6 minus 1 gives us 5, which is the correct output. So we can use inverse operations to find our inputs when given the output and the function rule. On your own, complete the function table given the output and the function rule to check for understanding. Example 5. Brianna bikes 12 miles per hour. The function rule that represents this situation is 12x, where x is the number of hours. Make a table to find how many hours she has biked when she has gone 12, 36, and 48 miles. Then graph the function. So we're given our function rule is 12x, and we know that x, which is the input, represents hours. We're given 12, 36, and 48 miles. So if x represents hours, then y must represent miles. So here I'm going to put 12, 36, and 48 miles. So we want to find the number of hours that she biked if she biked that many miles. So again, we're going to set our function rule equal to our output. So first we have 12x equals, our first output is 12. So to solve this, I would divide both sides by 12. We're left with x equals 1. 12 times 1 does equal 12, so we know that that's correct. Our next output is 36. So we're going to set our function rule, 12x, equal to the next output, 36. Divide both sides by 12. We get x equals 3. 12 times 3 does equal 36, so that's correct. Our last output is 48. So our function rule, 12x, we're going to set it equal to 48. Divide both sides by 12. We get x equals 4. 12 times 4 does equal 48. Now we want to graph the function. So each input is x and each output is y. And we know that our points that we use to graph are x, comma, y. So our first input is 1 and the output is 12. So our first pair is 1, 12. So we can plot it by going 1 to the right and up 12. Our next input is 3 and its output is 36. So we can plot that ordered pair by going 3 to the right and up 36. Our next input is 4 and the output is 48. So we can plot that by going 4 to the right and up 48. Because we don't have these exact numbers on the graph, we can just estimate where we think the points would be. So now we've graphed our function using the function table.